Hello? Can you guys hear me? Okay, all right. So I was actually waiting for someone, maybe Aditya, to give me a confirmation to go ahead, but looks like I've been made the host. So I'll just continue. Right, so I'll just take over from now. Okay. All right, guys. So first things first. Did you guys get the Jupyter notebook yesterday? And when did you get it? Okay. Okay, so I'm hoping you had a chance to go through it. Okay, if not, the second notebook, right? Not the first one. First notebook we have done. The second notebook is what I want to go over. I'll start sharing my screen. One second. Okay, so guys, let me know if you have some voice issues in between. I'm not sure if my internet connection at the moment is very, very stable, but just let me know if you have some voice issues. Uh, okay, here is the file. I'm not sure you can see my screen. You should be able to see it. Yeah, able to see my screen? Guys, can you see my screen now? Okay, all right, cool. Yeah, so this is this notebook should be there with all of you now. 1 second, increase the font size and just one small tweak. All right, maximum screen coverage. Yeah, I hope this is visible completely to you guys. Okay. All right. The file, which file? Okay, which file are you talking about? The Jupyter notebook or the notebook has been shared, guys, with you. I'm not sure. There were two files which were to be shared with you people. Anyway, there's not much in this notebook, so don't worry about it. There's not much. I mean, there's just 5 lines, so we will just just there's just five lines of code here. Don't worry. Just replicate. Start a new Jupyter notebook, and yeah, and I'll just restart and clear all the output. There's not much in this. There's just 5. All right, and okay, so you guys should have the files, and at least I'm sure the data file is with you. The CSV file had been shared with you yesterday itself, right in the beginning of the session. So you should have that. Everything should be on Slack. Just check. Yeah. So yes. So first things, the first usual steps: import the libraries which we need. Right. The basic libraries without any plotting or whatsoever are pandas and NumPy. And read in the raw data. And you remember, right? It's as simple as read underscore CSV for reading a CSV file. Right? And there's a lot of other methods in this. You can, I think in the previous sessions, when we had the marks data set, you remember we were reading directly from URLs. Yeah, I mean, CSV, those weren't locally stored. They were somewhere right on the web, and you were directly reading those files and so on. So there's a lot of reading options, reading from this, reading from JSON and so on. Yeah, but and typically you will have some CSV or some SQL query which you will read from a table. And then, so just as long as it is, let's say, structured tabular format, the read CSV and the usual stuff will work, which is more than 90% of the cases. The data is stored in such a fashion. But yeah, there are exceptions, of course, and increasingly that is becoming the case, that data is in a little different formats in JSON and so on. But again, I mean, when you finally do analysis and whatever, then you probably will get everything in tabular format sooner or later. Okay, JSON. Okay, I'm not expert on JSON, but this is one format in which these days unstructured data is being stored. So they are being stored as key value pairs or dictionaries and so on. You can think, I mean, I think the closest parallel to what JSONs contain over here, you can think of, like you have a Python dictionary, right? Like that. It's kind of like that. It's a nested structure in which, Python dictionary, you have the first key. In that key, you can have another, let's say, list or array or whatever. It's a very flexible and nested data structure, which is used typically for unstructured data. Okay. So yeah, you don't need to know it right now. Loaded, look at Hey guys, can you hear me now? Yeah, like I mentioned, I was having some network issues. I think this got disconnected. So yeah, I think it should be better now after a small change I made. But yeah, it should be fine now. Okay, so we should not be expecting anymore. Yeah. Let me share my screen again. Where were we? All right. So here we are, and we wanted to get some. So this is the part where we are doing some the exploration on data set, right? I just looking at it, what are the values, how many records, and so on, and we see, right, different kinds of columns, order priority, order quantity is definitely numeric, sales, discount, all these number fields, profit, unit price, shipping cost, all number fields, and so on, product based margin number field, all good. Okay, now then we wanted to see, right, what is okay, there is something or from the 5 records we saw order priority is low and high, but you wanted to understand, what is it generally like, what is more dominant, what is more prevalent, and so on, right? So to do that, to get the percentages of each, right, so without percentages also we can just get the values of each, or the number of times each occurs, yeah, by saying value counts. So you see that high, low, this is rather equitable distribution, right, of different priority: high, low, medium, critical, and not specified. Okay. The next thing you want to do is probably look at percentages, because these numbers are not very easy to mathematically or mentally calculate all the time, right? If I had 10 different things, I would want to calculate, right? This is this percent, that percent, and so on. So to make things easier, we say normalize equals true, and when you do that, you get this. They're all roughly around 20%. Yeah, pretty much. Like that. Another question was, what are the percentages correspondingly for ship mode? And you see most of them are regular air. There are some which are delivery truck, and express air. Okay. Now, from this, because this is I mean, retail data, and do have some notion of what this could be, right? That regular shipment is regular, right? I mean, regular customers maybe, and delivery truck possibly could be the larger things, right? Maybe because this is like, I think we remember some of these, right? These office supplies, and could be large appliances, could be printers or faxes or whatever, big machines also. So for some of them, maybe you deliver them by truck. And express air could be for very high value uh, customers or whatever, right? High priority orders, right? Where you just want to have it shipped or reach as soon as possible. So we have these different things, and so it's fine. Like that, for customer segments, we can also see, looks like corporate is the biggest, home office next, individual consumers buying smaller things is third, small businesses is fourth, but third and fourth are very close. All right, so this is how we wanted to do things for the categorical. Okay. I in terms of visualization, I will come to it, but let's first do the numerical, part of it, right? Numerically summarizing or whatever. Okay. The next thing we wanted to see was, what are the values in sales, like the sales column, right? And we said describe, and describe gives you very good summary, like mean, median, and then max, min, the first quartile, the third quartile, right? Standard deviation as well. So it gives you a fair idea. And I think, remember the discussion we were having yesterday, we were saying that the mean is far more than the median, right? Like 4 times. Then it just gives indication that there are certain very high values, and you actually see the max value is pretty high. Yeah. So, and even the 75th percentile is rather high compared to the mean. Sorry, compared to the median. So it's not like pure outlier kind of thing or whatever, but you do have some genuinely high values things over here. Some of these could be like big, because see, even the 75th percentile is 1700, and suddenly this is what, 50 times, not 50, yeah, roughly 50 times, right? So it's rather large, right? So this is worth inspecting, right? And we wanted to we'll inspect it later using some visual approaches and so on. And like that, if you wanted to do unit price, you can again right, do a describe and see the values. And let me also take one more column, which is for this, maybe you guys can do it, right? For where was the column? Product base margin. Okay. Product base margin. What okay, for the product base margin, the median value and the mean value, how different are they? And do you expect any, or do you, from this, do you sense that there are some extreme values? Okay. So for the column product base margin, so like a small task. There are extreme values. Yeah. Okay. Get this. So just get the same numerical summary for product based margin, and see if you, I mean, like you did earlier, right? You saw the mean, you saw the median, saw the standard deviation also. You, from all of these, you could get a sense that some high values, and there could be some very extreme values and so on. So can you do a similar thing for product based margin? And what do you see? Do you expect extreme? Do you sense extreme values or not? All right. So yeah, please go on, guys, and reply to me privately, of course, and don't just share uh, what code. I think code is obvious right now, what code we have to run, but the question I really want you to answer is: are you sensing extreme values in this or not? the mean, median, how far they are, and so on. Okay, all those things. Okay, right. So the code should be very clear, right? Like we did for sales unit described, like that you should be able to do for product based margin as well. Get the numerical summaries, and then tell me if you see a big difference between the mean and the median, the max values, and do you think there are extreme values or not? Okay. Okay, so there is only one response so far talking about the question. Anyone else, guys? Why is it that no one is responding? Okay, yes, I'm giving you a few more seconds, guys. See, the questions you guys have to answer is not how to get the number summary. Getting the number summary now can be done even by a 10-year-old, given that I have already explained for one column how to get the summary, right? Uh, Everybody would be able to understand, even the dumbest would understand that just instead of unit price, I have to use product based margin. So that is not the question. Okay. Question is, do you sense that there are extreme values? And so far, there has been just one response. Okay, so there is unable to read the file. I'm not sure. Me- Okay, guys. So I think it's rather clear to me, if not you guys, that this we can't proceed in this fashion. So what we can do is this. Um, Obviously, I can't expect you people, many of you people, looks like it now, many of you people to put effort and do things. So what I really want to do is limit the audience. I think that's a better solution. I'll limit the audience to, instead of having the 17, and instead of the 17 or whatever, I'm okay. At least I'm okay teaching 5 people who are actually interested. So I'll propose this. I'll maybe talk to Board Infinity guys as well. That let's have some sort of a. I think the moment the session starts, after the poll happens, or maybe yeah, before sessions sometimes. Let's have a quick small tasks given to you. And if you can't solve them, I think you it's better that those people be removed from the session. I think that's what is fair, because I it's not fair on the people who are practicing, right? That for them things move slow, right? And anyway, those who are not interested, it won't benefit them in any way, right? So that's what we're going to do next time onwards, guys. When the session starts, I'll probably have a 5 to 10 minutes whatever quiz or some tasks for you guys, and then only those who get some minimum marks, maybe they would continue in the session. I think the rest should be removed from the session. I think that's the only way we can have this. And I think maybe the solution for you guys would be take some time and join the next batch. I think that would be better, because you surely need some time. Yeah. So that's fine. I think because the guys who are interested, they are suffering because of the guys who are not, right? That's not fair for them. So let's do that from next session onwards. I'll just propose this, and I'm sure this should be okay with you guys. Have some assessment in the beginning, and if you can't answer those, you drop off. All right. And maybe you can be accommodated in the next batch whenever that happens, maybe a couple of weeks later or whatever, right? So I think that's what my plan is. I think the only way you guys can avoid that is by responding over here on very, very basic queries. This is not even something trick question right now which I've asked you people, right? Not even a trick question. You get it, right? But anyone who's able to locate their own ears should be able to answer this question. For unit price, I have done this. For product based margin, all you have to do is replace this by product based margin, right? And this is it. This is the first part where any not so smart person can also do this. Okay. If you guys are having trouble over here, I strongly suggest that for your own benefit, uh, voluntarily just go and tell Board Infinity guys that we want to drop out of this batch, because we definitely are not ready for what's coming next. Because you definitely are not. You're not ready for what's next. So you probably take some time, take, I don't know, a couple of weeks or whatever, enroll in the next batch, and then maybe things will be better for you. Okay. So this was the first part. It took about 10 seconds, right, to do this. And then once this was there, what we were looking at is what the distribution overall is like, and to assess if there are extreme values and so on. First of all, you can see the range, right? Minimum is 0.35, maximum is 0.85. Okay, things are between 0.114 and 85%. The mean and the median are very close, around 51, 52, right? So it gives us a fair idea that there really probably aren't no extreme values in this case. Okay, that was how simple it is. Okay, looking at a numerical summary. Okay, so that was as simple as that. Now, these are the numerical approaches to evaluate. But why stick to numerical values, right? Because um, number summaries can really fool us. I mean, uh, it's not really very intuitive also, right? The best thing is, of course, plotting, and there are multiple ways to plot. Okay, the first kind of plot we said was the histogram. So 1, 2, 3, 4. And for any kind of plotting, there are multiple, by the way, tools in Python also. There are matplotlib, and so on. Um, so matplotlib.pyplot is the plotting utility. This has I think this is that interface where you just MATLAB like interface, you just add things one by one and so on. And as PLT, this is a standard, you can call it whatever you want. And the other thing was inline. So inline is one of the backends. It doesn't matter, honestly. You typically just use inline. So just make sure whenever you're importing matplotlib.pyplot as PLT, also get matplotlib inline. Okay, this will make this is just basically render those, this backend will render those visuals. Okay, now uh, among the visual tools, the first one we saw what was a histogram. And histogram, what it does was, remember, it makes buckets or bins, it is called. Okay, it makes buckets or bins. And these bucketing, there is some logic, it doesn't matter so much, but we can control this a lot. Okay, we can control this a lot. We can say okay, first of all, the first thing we see that most values are around here, right, between 0 and 1000. There are very, very few items which are there beyond 1000 also, like very, 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 very few. Okay. And the other thing is you can control how this looks, right, what bins you have and everything. So you can say instead of having, I don't know how many buckets are there right now, but you can divide into 20 different buckets. You can also exert greater control by showing, I think, giving a range. Remember, I think we had done a range, right? Max, min, and so on. plt.hist, if I do, uh, there was some range as a parameter somewhere. Yeah, range, where you have to give the max and the min. So what you could do, I don't know, give the max value as 1000 and you want to, or maybe, I don't know, 100, and plot only less than 100. So range equals 0 to maybe 100. Yeah, because most seems, not 100, sorry, 1000, because most values seem to be in that range. Okay? Let me just do that. So yeah, so only the values between 0 and 1000 have been plotted. And like that, if I want to do it for less than 500, I can do. So you can exercise a lot of control over this. Range is 0 to 500 and so on. So, even in the 0 to 500 thing, you see that most of the stuff is less than 100 rather. Yeah. So you do see that there are extreme values in this, very extreme values, because of which maybe the entire thing was being just thrown off. Right. So this is one way of doing things. This is again frequency bars and so on. This is one way of doing this. The other, okay, there is a question, what is bin? So bin, guys, this is number of buckets to divide into. Each bucket is a bin, or each range is a bin. Remember, 0 to, if I see here, right, it is dividing 0 to maybe 300 is one bucket, one range basically. 300 to 600 is another one, 600 to 1000 is another one, and so on. Like that, it is dividing the numerical variable into smaller ranges and then calculating how many records are present in each range. Remember, that's all I can. I don't want to spend more time on that on histogram, all right? Because there's far more things we can do. Right. After that, we said this is fine, but still, this is like, where is the outlier? I mean, what and so on, right? I mean, from this I do see that beyond 1000 values are far and few, but still, it's very hard to visually inspect where are the outliers, how many, and so on. So one thing we can do is make a box plot. Okay? Box plot is look something like this. All right. And in the box plot, mm, 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 mm. Okay, 1 second. There are questions. There is not range is not there in the data frame. Okay, yeah, guys, I had discussed this yesterday, and I'd taken Excel. I had made some data points in Excel. I told you that some buckets are created over it, and then for those buckets, it finds which are present. I can also manually provide the buckets and ask it to plot in these buckets. So those ranges are not there in the data frame. This histogram makes those ranges first and then finds the frequency for the ranges. All right. So that's how ranges are created. They are not there by default. All right. Please study these basic things, guys. Mm, sometimes okay. Uh, hist output gives a numpy array. Hist output gives a numpy array. Yeah. So most of these methods will give you some sort of a calculation as an output, not just hist. So which is why I think if you do a plt.show, right? Plt.show, it will not. So if I, okay, I'll take this, I remove plt.show. If I plot this, you see it is giving you these numpy arrays. Okay. So it has the arrays and the corresponding frequency. This is what it does in the background basically. So, you know, these are the different bucket beginnings basically. Yeah, the different buckets it has created, and these are the corresponding values. Okay, so it calculates that if you don't want to, because it has to do a calculation in the background somewhere, right? So it does that first. If you don't want that to uh, appear, you just do a plt.show. How to improve this stats? What does that mean? Sorry, I didn't get the question. Can you repeat the question? How can you elaborate on the question? How to repeat? How to improve the stats? I didn't get the question. Okay. Anyway, so meanwhile you enter, I'll just talk of the box plot again. So yeah, so the box plot is one way of visually inspecting the data. It gives you multiple things. It gives you not just where the central tendency is, right? The median, but it also gives you a notion of the spread of it. All right, that most values are between this is upper quartile, this is lower quartile, right? Most values are first and third quartiles are over here, so most 50% of the values are in this range. It gives you that kind of an idea as well. Then it also, from using some logic, I will talk of that, some logic, Okay. All right. So you can see my screen, right? Yeah. So I was talking about the box plot, and so box plot gives you a visual representation of this. There is a median, upper quartile, lower quartile, and then in the box, right? So how does it get the name? This central part, right? This gray area, this entire thing. This is the box, right? In between, of course, this is the box, and these lines which stretch out, right? These are called the whiskers of the box. So, and if I just go to the Wikipedia page for it, right? Up, not this one. Let me just get this. It can be drawn horizontally or vertically also. Different packages do differently, but this is what it does. Okay, and this is a more detailed. So this right here in the center over here is the median. This is Q1. This is Q3. By now you should know what Q1 and Q3 are, right? And then this central piece is the box. Okay, these what extend out, these lines, right? These are the whiskers of it. Okay, and this bar here, the vertical bar over here, right? Or this vertical line or segment over here, this corresponds to this value, which is Q1 minus 1.5 times IQR. Or essentially, this is one way to say what is a low enough value, right? What is a, there's some sort of a criteria for an extreme value. Okay. If you think about it, and this other side, right, is Q3 plus 1.5 times IQR. So what's happening over here is the interquartile range, if you guys remember, gives is some notion of spread, right? That, remember when we were discussing this, we were discussing interquartile range as one measure of spread. Okay, because it does not really completely depend on extremes, right? Variance will depend on extremes, standard deviation will depend on extremes, but your interquartile range will not depend on the extremes, right? It will be on the central values. So interquartile range is one reliable way of calculating the spread. Now, using that, you can still get some notion of what a high value is, what a low value is, what an extreme value is basically. So this is what this box plot typically does. Okay? We take Q3 third quartile is a value, right? Because it could be a high value. So for example, in our case, if I go back to this case, right? If I go back here, where was the box? No, where was this? Yeah, these values. Unit price. Q3 75th percentile was roughly 86. Yeah. And if you see between Q1 and Q3, right? What is the difference? The interquartile range is, I mean, I'll round it off, right? It's just 79.5, but just to be safe, let's just say it is roughly 80, right? The interquartile range is approximately 80, all right? And if I take Q3, which is 86, what I'll say, 86 plus 80, which is 166, that is my cutoff for an extreme value. So anything beyond that is an extreme value. Okay, that's what this hinge in the box, sorry, not just one, say 1.5 times, right? So 1.5 times 60, sorry, oh, it was 60, sorry, my bad. 80, 1.5 times 80 is 120, right? So 85 plus 86 plus 120 is what, 206. So I'll say anything above 206 is an outlier. That is one way of doing this. On the lower side, 6.4, right? 6.48. If I see less than 6.48, I can't go minus 70 or whatever, because the lowest value I see over here is 1, right? So on the lower side, I can't really have outliers in this case. Yeah, I can't have extreme values in lower side in this case. But on the higher side, I can say Q3 is 86, IQR is 80, 1.5 times IQR is 120. So 86 plus 120, which is 206. This is my cutoff for a high value. And things beyond 206, I can think of them as outliers. Yes, Getting the idea, guys? This is what a basic box plot is. There are multiple different criteria also. Some people make this a little more complicated. I don't want to use 1.5 times. I want to use 3 times like interquartile range and so on. There's different methods, but this is one simple approach. Depends on what kind of data you have and what kind of values do you think are extreme and so on. But this is the most general form, which is also used probably in the general, most of the general box plot methods. Okay. Okay. So question is, how is IQR 80 in this case? Okay, roughly, I said roughly 80. Yeah. So can someone, okay, what is IQR? What is IQR? Okay, yeah, can someone help me with that? What is IQR? Okay, so Q3 minus Q1. Okay, good. Thanks, Rushan. Sorry. Q3 minus Q1. What does Q3 value over here? 86 roughly. You know what Q3 is, by the way? Q3 is 75th percentile. It is 86. Okay, so roughly 86. 25th percentile is 6.4. So actually it is roughly 79.5. But to round off, I made it 80. Just for ease of calculations. Okay, so yeah, 6.5 roughly that would be our IQR. And 1.5 times that IQR is plus 75th. This would be my threshold, right? So this threshold is where this hinge is at. This is the hinge. Okay, hinge, or some people call it fence. Okay, hinge or the fence, upper hinge or fence. Okay, these are your qualifiers for your extreme values. Things beyond these are extreme values. All right. So that's what the box plot is. So now let's go ahead and prepare the box plot. First, let's prepare the box plot for our product based margin, because I think that is the more well-behaved variable, right? We saw that. So how do we do this? There's multiple, again, ways to do this, but the simplest one is matplotlib box plot. So plt.boxplot. Yeah, please do this as well. plt.boxplot sales 0 product base margin. All right. And plt.show. And when I do this, what happened? Invalid value encountered in percentile. Or maybe there are some nulls over here. Okay, let me just check. Oh yeah, there are some nulls in this, right? Yep, there are nulls. So that's why there's some problem. Okay, I'm sorry. There's a lot of nulls actually. It's not very few. 63 values which are nulls in this case. Let me do this. I can talk of removing or treating nulls later. But for now, I will make the plot where this value is not null. Okay, that's what I'll do. Okay, so maybe a simple step. If I just go back, how many nulls were there? I did not do that. Okay, let me just see. I think this is the only one where there are nulls, right? Nothing else is null. Okay, so if I fill these nulls, I should have a complete data set, right? Okay, let's talk about that then first. Let's talk about this case. This is the only place. So let's me sales 0 dot is null dot sum. This will give me for each column. I see there are no nulls except for this product base margin. If I fix this, I will have fixed the values in the fixed the values in the data frame. So either we talk about filling them, or we can talk about removing them. Again, like I mentioned earlier, let's remove them for now, because filling them, this will come in a little later. All the approaches will make more sense later when we are going towards predictive modeling. But for now, because we are analyzing this, let's just drop them. Okay. And what I'll do is, I think you guys should remember there's a couple of ways now to do this. The first approach could be sales 0 dot drop NA, right? And I say subset equals product. I'll just copy it from here, right? Product. Why makes the same mistakes again and again, spelling mistakes again and again. Okay. And here access by default is 0. So the rows are gone. I'll just make a copy of it. Sales 1 equals to this. Okay, so that I don't alter the original one. Yeah, this is better that you drop. Okay, so this will not update the original one. It will just make a copy with the rows dropped, the sales one. Okay, and dot shape I'll do, and sales 0 dot shape anyway. You guys know it, 1889 dot shape. If I drop this, okay, so 8366 is what you finally have in sales 1. Okay, now now I can do all those plots because I think this is what is happening, right? So let me do this. Let me make the box plot from sales 1 now, because that has everything. Aha, this is what the box plot looks like. Okay, and you can see it's a very nice, well-behaved box plot. First of all, are there any extreme values based on that criterion? Well, no, because nothing is beyond these hinges or fences. Okay, hinges mean whatever you call it. Hinges. This is the whisker. This is the hinge. Nothing is beyond these hinges. So therefore, you can clearly say that there aren't any extreme values or outliers. And you see the median somewhere is around 52, which is what we had earlier also, right? And the quartiles, right? The lower quartile is toward 25, 30 something. Yeah. Upper quartile is somewhere around 60. Third quartile. Now, and you also see that this part of the curve is hell heavier, right? There is more stuff in this range. I mean, this part extends a little more actually. But I think after the median, there are values for a short time, and then there is, some much higher values suddenly. So this just tells you, gives you some notion of, what the density is also like, right? Because there is things are more spaced out between first quartile and median, right? Things are less spaced out between median and third quartile. So there is more heavy occupation over here. Things are more spread over here. Okay, that's what this means. Sorry. So a box plot is a very, very important visual tool. All right, this is definitely one of the things you should do. Now let's make the box plot for unit sale, unit price. So I'll take this, I'll move this up. Okay. Yeah, but it is fine. Yeah. So this is what it is, and yeah, let's make it for unit price. It's too big here. Yeah, it's better. The unit price, if I make this, ooh, look at this, right? Even the upper fence or upper hinge is somewhere like very close to, I don't know, it's 200 not, can't even see because the scale is too compressed over here. Somewhere around maybe, I don't know, 150, 200, whatever, right? And all of these values are very, very high, much higher than any quartile or, even the upper fence. They are far above the upper fence also. And these, 7,000 or like probably can be considered outliers, right? In this case. So this is surely not the same kind of stuff like earlier. Okay, very, very different. So this tells you that there are, I mean, what you could look at those numbers, some of these earlier and histograms, but this tells you that, even the upper fences are like far below 200 and so on, and things are like much higher than that. All right. I'll do it sales 1 actually. Should we have sales 1 everywhere? Yeah, it's same, nothing changes, but yeah. But these are definitely very high values. You see values are continuous until around 1,000 maybe, or maybe even, but after that, they're just like limited 2-3 values which are above that. Right. So if I, okay, let me examine what these high values. Okay, let's examine the very high values so that we can see do they make sense or are they because of some sort of an issue? The question is median there. Median all are there. They're just compressed so much you can't make them individually. Okay. Let's examine the very high values, and let's examine the values above 2,000, right? What are they? So let me take sales 1 and sales 1 dot unit price. Okay. Unit price. Oops. take those records wherever unit price is greater than 2000. Yeah, they should give me that. And what are these? How many orders are there? Oh, there are plenty of orders actually. It wasn't just 2, 3. I think there are many, but just overlapping, so you can't see them. Okay, there are a few. Let me see the shape of it first of all. How many are there? 33 records. Okay, and what are those records for? Delivery truck. This is fine. Let me go to the category, subcategory. Office machines, copiers, and fax. Okay, this makes sense, right, guys? Other stuff could be much cheaper, right? Staples or papers and so on, but definitely fax machines would be much more expensive than just a paper, right? So these, I don't think these values are wrong as such. They are correct values. They are just high. I mean, it has to be high. See office machines and so on. So these would be high. And if you see office machines, what is the unit price? It could be fine, right? $6,700 or whatever, right? So these could be more expensive machines. On the other end, you have some very cheap stuff also. So I'll just make some unit price, let's say less than, I don't know, 20, right? And just do a dot head to see a few records. See, what do you have over here? Paper. Unit price is what? $8, $3, $6, and so on, right? These are what? Papers, binders, and so on. Smaller things. So it makes sense because the companies diverse, the offerings are diverse. So you will have a paper which could be $2 also. The unit price. What is the min? Sales 1. Unit price. Describe. The minimum is somewhere around $1. You have something for $1 as well. And you have something for $6,783 as well. And these are not problematic. See, these are what they are, right? These are genuine values. So this is one idea I want to put in your heads, that high values does not mean rubbish values. Okay. Many would tell you, okay, these are outliers, drop them. Okay. That's not the best approach. In some cases, they are there. They are genuine. Now, should you drop them? Well, it depends on what you are doing. Okay, depends on what you're doing. If you want to understand, I'll give you a small example, right? if you eventually want to, let's say, I think the same example that we had earlier in the session, probably stats sessions. If you want to, let's say, take the average salary of people, I don't know, in a particular area or whatever, right? Or maybe, take the average salary of students from graduating from a college, right? There you will have, 5, 6, 7, 8, 9, 10 lakhs or whatever. And then you will suddenly have some guy, a couple of guys maybe who got placed in Google somewhere in USA, right? And their values will be what? 80 lakhs, 90 lakhs. So would you want to use their values when reporting this, right? You may not want to use it. So if your purpose over there is reporting the average value, then this is an outlier. You don't want to use this. So in that situation, maybe it's an outlier. But if you want to maybe do a different kind of activity, let's say you're trying to make a model to understand what are the factors which make someone earn a package in the US or get a job in the US, right? Then in that kind of a predictive model or whatever, then this will be a very important thing to get, right? That these two guys are the, cases where this is what you have to identify. This is a very important thing to retain. So depending on what you're doing, right, high values can have different utilities. So don't just, so I'll just summarize what I'm saying. I'll just summarize what I said. So there are a few things about high values or outliers. Okay. First part, identification. Identification of, and let's call it identification. Then there are several approaches, right? Um, this IQR based approach is one of many. Okay? There are many others also, by the way. Then, once you identify what kind of action, handling, or how do you dealing, right? How do you deal with them? Uh, well, answer is depends on the task. These could be genuine values, right? This is what I'm trying to say. These could be genuine values and very reliable as well. Depends on the task and how you deal with them, right? This is what I'm saying. Drop these records only if you are sure you don't want them to influence your task at hand. Okay, that's it. I'm not giving you drop this or drop that. I'm telling you that their approaches to identify IQR based approach is one of many, very common one. Dealing with these could be genuine values and reliable. Depends on the task at hand. Drop these only if you are sure that for your task these don't matter. Otherwise, don't drop them. Okay, maybe you do something else and all. There's multiple ways. Okay. We'll come to those ways again later sometime because there's something we have to discuss later, transformation and so on. So we have to come back to again. But again, high values and outliers, don't drop them. People will tell you drop them, don't. Okay. Now this is, I think I told you this is one one approach. Okay. Another approach to dealing with this is the standard deviation based. So it's called a K sigma approach. Okay. Anyone know what a K sigma approach is? So what you do is, if you go back to the normal distribution or whatever, right? Okay. Remember the normal distribution thing? Yeah, I'll open the probability distributions. In the normal distribution approach, what we said was this. We said that things, from the center, from the mu, in the normal distribution, 1 sigma, 68% values are contained, 2 sigma, 95% values are contained, 3 sigma, 99.7 are contained. So what you can, one way to approach this outlier thing is that, assume this normal distribution kind of a setup and say things outside of 3 sigma are outliers to me, but things outside of 2 sigma are outliers to me. This is another approach because this is the kind of thing we do in hypothesis testing and so on. Remember, this value is very, very far away from the mean. Therefore, it is probably by chance on some sort of an anomaly, right? That is something you can do. That is another approach in detecting, identifying outliers, all right? So, but, and people use it very, very commonly, left, right, and center. But I would not advise doing this very commonly. Okay, so let me just show you one more. This one I will not explain to you. We can come, maybe you can read on it or look at it later. So this one is not about square or anything. This is median absolute deviation, or it's called MAD or whatever. And this this is, instead of taking a variance or like a standard deviation, it calculates something like a median absolute deviation. It takes all the deviations from the median and does a median of those, takes the absolute value, and you can read about it actually. It is another way of identifying some sort of a spread. And then from the median, you will say, things at least 2 MADs away or 3 MADs away or whatever, they are outliers. So there are multiple approaches. IQR based is one of many recommended, right? First approach from my side. Okay. And then there is a K sigma approach, commonly used, but use with use only if you understand, or I don't know, commonly used but use carefully or whatever, right? Use judiciously. I don't know how to uh, put it now, but yeah, you get the point, right? That is it okay to assume the data is normal distributed? May not be, right? So uh, that's what I meant over there. Anyway, so yeah, this is a few ways to identify. Then dealing, like I mentioned, depends. Okay. So in this case, right now, let's not do anything for now. Maybe when we're doing certain views, we may want to exclude those records, because see what happens in this case is these are machines. Okay, these are office machines, and these are actually much higher price than the others. And let's say I'm analyzing, something else, then maybe, this will skew things. I probably don't want to report these. So maybe sometimes I will want to remove these cases. Okay. If I'm analyzing anything to do with price, but if I'm analyzing orders and all, it doesn't matter how many orders are being made or which areas. It doesn't matter so much. Okay. That's okay. So this is one important part, guys. High values outliers. How do you detect outliers? Um, this part, make sure you once I share the notebook, make sure you go over this again, understand the box plot, definitely read about the K sigma approach and the median absolute deviation based approach. This is very important that you know what these are. But these top two are highly recommended to know. The bottom one is a very good bonus. No one expects people to know the third one, but if in an interview someone you talk of this, this can be a very good added advantage to you. Okay. So yeah, but the fact that you mention that there are multiple approaches, this, that, and so on, that itself will give you a very good edge in any interview. If I were interviewing you, and if I ask you, because I will ask you questions, so about these basic stuff, how do you identify outliers, how do you handle missing values, right? That is what really tells me if someone has practical knowledge or if someone is just finding code of the internet, or just I don't know, reading things off of somewhere, right? So I will definitely ask these kind of questions. And if you respond saying that there are multiple approaches, I could look at IQR or K sigma, and then that will make me really happy. All right. So that will be a really good bonus. So make sure you go through these. Okay? This is one. Let's come back, continue with our analysis. This was an important one, so I spent enough time on this, because this, right, along with handling missing values, these are just ignored. I don't know why, but these are very important, and they completely screw the results of any analysis or model you're building afterwards. It's just crazy how people just tend to downplay the importance of these things. I'm just surprised, but yeah, these are very important. All right. So anyway, so going on, box plot, if I make for unit price, I saw that there are very extreme values. I saw that these machines and stuff. Okay. At the moment, I am not dropping anything. I just understood that they are for a certain reason. Okay. And that is a genuine reason. When later I'm doing something, I may want to drop it or retain it or whatever, right? So, but now I'll do nothing. Like that, I can make another box plot for where is that? Where are the columns? Yeah, I can make it for order quantity. All right. Oh, there's something. Oh, profit. No, profit is overall profit. Okay. So order quantity. Because most orders you expect to be certain quantity and so on. Let's see if there are any extreme values. So order quantity. Oh no. Okay. Order quantity seems to be rather well behaved, right? Between, I don't know, 1 to somewhere around 50. All right. So order quantity is a little better behaved. So yeah, this is good. So like that, I can look at all the different columns, guys. So whatever we are doing this, by the way, so far, right, looking at individual variables and so on, making histograms and box plots, all of this, right, all of this stuff is called univariate analysis. Okay. What does that mean? We are doing analysis of one variable at a time. So we do not look at two or three combinations, right? We just saw this variable, how this is. We do not say how this variable relates to another one and so on. So this is called univariate analysis. Okay. And this box plots and histograms are very, very popular tool for univariate analysis. All right. So, okay. Let me make the box plot for one more variable just to see if there are more extreme values, right? Where are the columns? Regions, customer segment, base margin we have seen, order quantity we have seen, discount. Yeah, let's see discount, right? How discount varies and so on. That'll be an interesting one. Heavy discounting, bad discounting, good discounting, and so on, right? All of those things. Okay, looks like discount is also rather good, right? You have these three values which are a little higher, but it's not like they are like very, very far away, right? So it's like the upper fence is somewhere around 16, upper hinge is somewhere around 16, and this is what, 17, this is 21, this is 25, right? So they're not like very far away. It's not like upper hinge is 16 and they are at 50, right? So, okay, this is also fairly well behaved. And if I make a histogram, you'll see plt.hist. I can do this, sales 1, discount. If I do plt.show, yeah, it's not like, very far away. There's maybe just a couple of, just one value over somewhere, okay, and so on. So this is definitely these are definitely well-behaved variables, no outliers and so on. Outliers are probably only these sales quantity, and I think if I do a profit, the probably profit also may have some outliers. So let me make profit as well. Yeah. Oh, okay. Profit is like okay. What kind of graph is coming up, guys? What kind of thing is this? While it's not completely one-sided, you do have very high values on both. So distribution is like, it's all over the place. It's not like concentrated in one particular range. It's all over the place. And if I make a histogram of it, I think it'll be a little sales 1 dot profit. Okay, plt dot show. Okay. Oh no, it is like that. There is a. How much is this? Okay, let me make bins. Bins is 20 something. Okay, yeah. So around I don't know, between 1,000 to plus 1,000, you have most of the values. But there are cases where you have extremely good profit, extremely bad profit as well, right? Negative profit, maybe order returns or whatever. So both things have been there, right? There's extremely high, extremely low as well. Okay. Now, yeah, could be like a normal distribution. I can maybe change the range over here to maybe maybe go between minus 1,000 plus 1,000, right? To plus 1,000. See, so much better, right? Bins 30. Yeah, this is. I think Rushan has the right view. It is not very different from. It's a symmetric. It's not a very symmetric, but yeah, you do see a good peak distribution. It does seem to be closer to a normal distribution, not a standard normal, but like a normal distribution. Yeah, center. It's okay. It's that kind of a thing. It's symmetric on both sides, and you do have some very high and very low cases as well. So those could be those bigger orders which are probably returned. I don't know what, but this happens. Okay. So yeah, this is an interesting variable with high negative as well as positive values. All right. Minus, what if I do minus 500 to plus 500? What does it look like? Yeah, it's getting more and more like a normal distribution, right? Yeah. Anyway, cool. So this is the kind of data we have. So see, this is how you can control things. This is how you can look at things, right? All right. So we have analyzed most of the variables individually. Let's now also univariate analysis, right? Let's also do some visual part of it. Okay. See, there are so many categories in this visual analysis of categorical variables. We looked at plots for numerical variables, right? For categorical, we didn't do anything. right? So what kind of plots can I do for a category, by the way? Anyone? Hmm? Guys? For categorical variables. Okay, yeah. Pie chart is one answer. What others? What else? Okay. You can do bar charts also. No, line charts won't be a good idea. You can do bar charts. Okay, bar charts and pie charts. You have two options. I will recommend not using a pie. I used to use pies long time ago when I was in the consulting industry and so on. But it makes sense when you really want to show that distribution of things and spread. But I realized later that it's not very easy to read also actually pies. It's better to avoid pies. There are a lot of other alternatives to yeah, by the way, very interesting thing. I mean, I thought it will be interesting to you guys. I'll share that with you about pie charts. I just this is not to myself. Okay, share the example, apple example with you guys. This is not for myself. I'll share this with you guys. Okay, to do so that I don't forget. But yeah, for categorical, you have pie charts, you have column charts, the bar charts. You can think of them as similar actually, and then line graph. Okay, so line graph, not really. Line graphs, you could use line graph for category, but you should use them when you have, let's say, a particular order in the categories. If you don't have an order in the categories, it's not a good idea to put a line, because when there is a line, right, automatically your mind starts to look for a trend, and if trend is not there, then it's not the best way. See, the point of visualization, uh, I mean, yes, I mean, this is a big discussion, but visualization can be used for multiple things, right? But often it is for either analyzing something for yourself, or it is about communicating some insight to someone else. Okay, so in the analysis or looking things for yourself, you can do whatever you want, right? You can say, I understand this better, I just think differently, so I will draw these differently. Everyone likes pie charts, but I like some different kind of a chart. Let's say tree plot or whatever it is called. Okay, which is fair. I mean, you can do whatever. But finally, when we are communicating the results, or when you're making a presentation for someone else, in that part, in that situation, you have to look at what the audience understands most. Okay, so there's two different things: making a visualization for yourself versus making it for someone else. Okay, typically you are finally you are giving a result to somewhere for business and so on. You have to make sure you use the charts which they understand. For your own, you can do whatever, tree charts or whatever and so on. Okay, anyway, so coming back, there are uh, pie charts, there are bar charts, there are tree charts, and so on. I mean, all of these are there. There's a lot more actually. These are not the only three. Okay, but pie charts, you guys know what it is, right? So pie charts are to do with proportions. Okay, yeah, also by the way, pie chart by default is proportions. Okay, so if you don't want to show proportions, the pie chart is out of the way. And this is relatively like, just to get a sense that this is more prevalent, this is less prevalent, and so on. And it works on the areas of things. Okay, in this case, Australia, Canada, and others are the smaller ones. UK is the large one, and the biggest by far is USA in this. Okay, now this is a fair representation, right? And this is extensively used in consulting industry and so on as well. In one view, right, in the executive dashboard or whatever, you can have 2 3 pie charts, maybe smaller categories. This is a dominant one, this is a dominant one, and so on. Respondents yes and no, 80% by yes, 20% by no, and so on, all those kind of things. This can give you that kind of a view very easily. But you look at these, right? Look at this: Canada, Australia, others. I personally am not able to identify, right, which then was significantly bigger. For me, Canada and others look to be exactly the same. and Australia is little slightly lower than them. I'm not sure how you guys seen this, but for me, Canada and others are like exactly the same, and Australia is a little lower. I don't even know how lower, because at this level, calculating areas is not very intuitive to me, guys. UK I can see is much bigger, but how much bigger? Is it 3 times the area of this? Is it 4 times the area of this? Yeah. So this is not really a very good idea in my mind, and I think I have stopped using pie charts for a long time, except for a situation where that's what it requires or that's what the people are used to. I don't really use pie charts. I can still use pie charts if there are only two outcomes, yes and no, or whatever, three maybe, so that things are still very easy. But here, this is just, I don't like this idea of using a pie chart over here. Okay, and I'll show you a very interesting example. And see this, right? This notion over here, pie charts are not actually very easy to read. It's not very intuitive to read, right? And this notion is actually exploited by people as well. So I can, I can show you some example. Yeah, you put labels and all, but see, it's still not very easy to identify which is bigger, which is right. See, look at here, right? 4 and 9 case, right? I don't know. I mean, just like this arc is so much larger, right? How do I mentally assess that this area is almost twice or just slightly above twice and so on, right? So it's not very easy to interpret. I'll show you how. Yeah, you can look at the labels, but first thing humans will do is look at the uh, graphics and patterns. That is what very attractive. Okay, and then you can see. But the point is, if you're putting labels anyway, then why have this kind of a confusing thing, right? There's so much better you can do on this. Okay, so I'll talk of that, and I'll show you some example. I forgot. I don't know how to search for it. Steve Jobs, Apple, Nokia, 3D pie chart. So there was a presentation, and this guy is just straight out lying. All right. Okay, and this is a very very good example of why this is a trick. This is not a very good thing to do. Of course, I mean, I would never recommend lying with statistics and lying with data. But what this guy is doing is, I mean, they know that it's not very easy for us to, you know, visually assess those areas very quickly. And what this guy has also done is he has tilted the axis. Okay, tilted the axis. This is like, I think this is straight out line, but yeah, tilted the axis. It's a 3D now, and he's rotated it, shifted it backwards. So what he has done is, this purple one is Nokia. Okay, the purple one is Nokia. This green one is Apple. All right. Now what he has done is, if he had a regular flat pie chart, right, you would have sensed that Nokia is a little larger than Apple. The labels are there, but still, I'll tell you again. Okay, so, but what this guy has done is tilted the axis a bit, and if you see labels, you read later. Okay, labels also like lightly colored, but first glance when you have a look at this, it stands out very significantly that green is bigger than purple. Okay, so 19.5 looks bigger than this. While the people will the next level is they will look at the label and so on, but it just it just looks it just comes out that Apple is bigger than Nokia in this case, which is completely false. So pie chart, first of all, they are not very easy to read because it's very difficult to compare areas visually and so on. The second part is with these smaller things, so it's very difficult, right, for you to assess. It's very easy to trick. If you had not put the labels over there, you would have definitely Apple is bigger than Nokia. This is wrong. Okay, so I would. This is a very good example of lying with things, and why you should not do this. I think if they had tilted, I think this is a nice image. If they had tilted, if he had actually done it the right way, it would have looked something like this. Okay, where purple was bigger than blue. All right. Nothing. So purple is bigger than green, and then because of the perspective, it was looking smaller than green. So this is one good example why, I don't know, the pie chart is not very easy to read and interpret. It is, I would say, avoid pie charts. Okay? I would say better go with bar charts or stacked bar charts or whatever. All right. Okay, fine. So tree charts, forget it for now. This is useless funky stuff. And there is bar charts. Now bar charts are the better one. I think this Apple example is gone. So we'll draw bar charts, okay? And by the way, making a pie is very easy. plt.py, okay? plt.py. So you can just figure out what x, explode, true, false, colors, auto percentage, or whatever. Let me just make a pie chart in any case for you guys. Sales 0 dot what had less number of values. Order priority, but value. No, let me take something else. Ship mode. Ship mode had 3 values, right? Yeah. I can make a pie chart for this. Let me take sales 1. Yeah. Ship mode had 3 values. I'll say plt.py. I just need to give what. Oh yeah, I have to do, sorry, I have to give value counts for it first. Yeah. Then I can tell you to give labels or whatever. I'll not get there, okay? But yeah, you can give labels or whatever and all those things, right? Labels equals to, yeah, I mean, you can do this sales or value counts dot keys or index or whatever. But yeah, you get the idea, right? It's rather easy to, okay? You can give the exact values or you can say normalize equals to true. You can give the proportions. And you can say format or whatever. I mean, there's a lot of stuff you can do. Let's not worry about it, okay? But yeah, you can do this rather easily, okay? So pie charts can be done like this. This is one. And we'll use bar charts. So what do we want to do? We want what is the frequency of each one of them. We want to plot that. Okay. So plt dot bar, and in bar there are two. There is bar and there is bar h. Okay. Bar is the usual vertical, h is the horizontal. So if I say plt dot bar, if you see x, what is the height? So you have to give not just x, but also the height of it. Okay. So I'll just talk of it, what it is. This PLT bar chart needs separately the labels and the values. Okay. So, okay, well, I'll show you this. And I'll tell you why there's a better way to do this. So what do I want? I want this ship mode to different values of it. Okay. So plt.bar, I want to plot dot value underscore counts. Okay. Or just to make the code a little more concise, what I'll do is this. I'll call it CTS or frequencies, FREQS. Okay. The freaks is this. It has the index, right? And it has the values. Okay. So what this bar chart needs is the index, is the values and the index. The index will be your X, so dot this, and these will be, heights would be the values. And this is what it does. PLT dot show, if I do regular air, delivery truck, express air. Okay. This is the basic frequency chart. So you get a notion, and see, this is so much better to compare, right? Delivery truck, express air, and so on, right? I don't know if you look at here, 970, 1130. These are not very, very difficult. It's not very obvious how different they are, but in this case, you do see the difference in the height. So bar chart is far better way to do this. All right. So I'd suggest using a bar chart more than anything else. Okay, for categorical values. So this is one. So this is one way where first I get this value counts into the freaks, and then the freaks I use to this. Now there is another way, which is a little shorter way. I mean, I like it. It removes the need for an intermediate step. Use the pandas plot, pandas series plot method. So interesting thing is, so this you were using matplotlib, pyplot, right? All of these, plt, right? You don't need to do it all the time. If you have data frame, okay, so I'll answer. So data frame, pandas data frames has methods for plotting. Okay, just listen carefully. Okay, methods for plotting. So if I look at, let's say my discount variable earlier, right? Let's say sales one dot discount dot. This is a panda series. Okay, if I do dot pl, I see there's a dot plot, and if I see there are area charts, bar charts, horizontal bar, density, hist, KD, line, pi, and so on. Okay. So, but what is this? Does it mean pandas has its own visual capabilities? Well, actually, no. This pandas methods uses matplotlib at the background. So essentially, it has just simplified the coding for you. It has written some functions. Pandas has written functions for you to make this very easily. So how do I do this? For example, the pie chart earlier, right? We wanted to do, instead of doing all of this long stuff, right? Getting the value into one. What I could simply do, sales one. I'll just take ship mode over here. Okay. Dot plot dot py. Oh, sorry. Oh, sorry, not py. Sorry. What do I want? Yeah, plot dot bar. Bar is what I want. Bar. Hey. What did I do wrong? Let me check. Oh no, first I have to aggregate to some number kind of thing, right? Okay, dot value underscore counts. Yeah, dot plot dot bar. Correct. Right? This is clear, right? I mean, and if I want to make a pie, dot pie. Done. Ship mode, regular air, express air, delivery truck labels. So much more convenient, right? So that sales ship mode, I do value counts to get to the numbers, and this will be a series, and dot plot dot py. Done. This is so much better. It does a labeling automatically. This kind of for automatically for yourself. If you want, you can add some more criterion, some more parameters, and so on. You can add the labels and so on. Where is this? No, it's not showing that. Oh, it's showing .py. Okay, anyway, I don't think it is identifying it, but labels equals to. I don't think true will work. I think you have to provide the labels. Yeah, labels equals to. Yeah, I think include. I have to figure out what exactly it needs, but for now, I think it's okay. But yeah, you get the idea, right? It's so easy to plot over here with this. I don't have to have a separate step. Value counts dot plot dot hist will, oh sorry, hist, sorry, bar. Bar will give me this. If I want to have a horizontal bar, I simply do bar h and done. This is easier to read again, right? Express air, delivery truck, regular air. Guys, you getting this? All right, so this is, okay, question, why to include labels in the pie chart? Because it's better to include labels so that you can compare, because visually it's very difficult to compare. It's better to compare numbers, okay? Okay, so this is good. Guys, you guys with me on this so far? All right, so now, so pie chart and all, you have know how to do it. Bar charts, you also know how to do it, okay? Now, like this, you can do for so many other things, all right? One second. Yeah, so yeah, I was actually coming to customizing. So far we have built a couple of types of plots, right? We have built box plots, we have built histograms. We haven't really customized anything. Okay, we're using whatever colors they have given us. uh, you want to customize sometimes, right? So how do I do this? How do I customize this? So all the matplotlibs, they will have some sort of customization options available to you. There's multiple ways to customize. Okay, so first way would be over here to just say add color. Color equals to, and there's different color codes you can give over here. You can say green like this, it becomes green. Okay, or if I say color green over here, everything becomes green and so on. So you can customize these, you can customize individual elements, saying the color is green, this, that, and so on. You can also use different styles of plots themselves. So one second, huh? Style, okay, and I will just draw plot, some plot. I think this plot only I'll just draw without the color green part. Sorry, style dot use. Hmm? Oh, sorry, it's not ggplot2. I'll just show you this. Huh? There's some styles available. It's ggplot. It's not two. Okay, sorry, my bad. Sure. Okay. See what happened? Very, very different kind of a plot coming up. See this, right? I can say color equals to cyan or whatever, or blue. And a very different kind of a plot coming in, a different kind of a grid. So what did I do? Okay, so GG. GG stands for Grammar of Graphics. Okay, let me talk about this. Different styles available. So what are different styles? So okay, what did I do first of all? I say matplotlib.style.use. Okay, it's a style module in PyPlot, and there are multiple available. So what are the available options? I'll say plt.style.available. I have all of these available: Seaborn Dark, Seaborn, Solarize, Grayscale, ggplot, and so on. Okay. Let me do something else. Okay. Let me draw the default. Okay. Let me get back to the default ones first of all. And for resetting things, okay, no colors over here. Okay. And sorry, there's one more thing we have to do. There's some stupid thing in my uh, Python version. Yeah. Have to reset everything. Okay, so if I use a default when, right, this kind of a thing, this is the kind of stuff I have, right? Default, express air, delimiter, regular air. Now if I want to use a different style, what I can do is this. What style do I want to use? Let's say which was that, what are the available ones? Yeah. Mm. Dark palette. Okay, Seaborn dark palette. I'll just take this one, Seaborn dark palette. If I plot this, yeah, it's very, it's a darker, much very different kind of a palette. It's a different color palette as such. Okay. If I want to use something else, let me use Solarize Light 2. Yeah, Solarize Light 2. See, it's a different one again. So you have different kind of these color palettes or different styles available for you. All right, and depending on what you like, you can choose them. Right? I mean, I don't know. Different people have different ones. There is a very dark one also. Where is that? Forgot. Anyway, there's a dark background. This is a very different one. A completely black and so on. See, it's very, very different. Question is, how do I change the color for different bars? Okay, so you can actually provide. Uh, okay, so color. If so, okay, one second. Mm, so where is that? Let me do this. Sales one dot discount dot plot dot bar. If I look at the method for this, okay. No, oh shit, it's not showing that. But okay, so let's say normal plt dot bar when you do, right? Plt dot bar when you do, you can see, whereas in the kw args, where is the color part? Okay, yeah. So it's like this. You can either provide a single value scalar, right, which we have done, like everything is green, or you can provide an array. Okay, saying that I want, I want, one second, I want this to be red, the others to be green or whatever. So let me do this. Let me do this. Let me go back to the default one because that's where the colors will be clear, right? By the way, don't worry about these stupid things. First, get the whole plotting thing right, then worry about individual. But yeah, okay. Listen. Now here I can provide color. I can provide one value for each. Okay. I can say express air. I want to have red, and everything else can be green and green. Oh, sorry, it's in the other order. Yeah. It's but horizontal bar, right? Yeah, sorry, my bad. Horizontal bar starts from bottom. So I want regular air to be red, everything else is green. This is how I do it. Okay. If I want express air to be red, then I'll probably do this. Okay, and so on. So I can control these elements completely. Okay, that's how I can exercise a lot of control over these. All right. You see, right? Simple syntax is just the same. You can just use a different style or whatever. You get very different looking plots. All right. So yeah, so try it out later. See what plot makes more sense to you. I typically stick to either the default one or the Seaborn kind of stuff. Okay, I don't go beyond these too much. Okay, yeah. So that's about making bar plots, right? So bar plots just to, and this is again a univariate bar plot, right? Which is more like express air versus delivery truck versus regular air. How many uh, what is the presence of each and so on. All right, that's one. And as a thing, let me just check if I can do this over here. um, Sales one, let me just copy this. I'm not sure if this will work. I have to figure out the syntax for it, but let me see. It has no property stack. Okay, so this will not work in this case. But yeah, fine. I'll show you some different examples somewhere else in bivariate analysis. Okay, so yeah, so this is what it is. Um, you can do univariate analysis on categorical and numerical features, and you've seen different kinds of plots you can make, right? By the way, one more thing, you can also change the figure size of it. Okay, so for example, this I'm making over here, right? I don't need all this funky stuff. Okay, let me get rid of this color and so on. Okay, or forget about this. I had sales one dot discount, right? If I do hist, actually I didn't even need to do plot. I think the hist was straight away. Or let's say box plot. Okay, no, but plot dot box. Okay, if I were doing this right, I can change the image size of it. So I can say plt dot figure. Okay, this is like matplotlib figure, and I can say fig size. These are again, guys, minor things. I would rather prefer that you guys play with it, these parameters, instead of me teaching you these things, right? I don't know, 4 by 6 maybe. Okay, or 3 by 6. This is much different, right? This is more like, it's not unnecessarily spread, and this is like extends this a little bit more, right? This is a lean one, but yeah, in this plot, height is what I care about. I don't care about the width of this so much, right? So yes, I can do this, and also by the way, here also I can change the color equals to green or whatever. Okay, I think dark green also works like this. Yeah, whatever. So these color codes, and you can just figure out online. Matplotlib page I shared with you guys, right? It's very very useful. You can do these kind of things. Okay, so and so on. So like this, you can customize these things. You can change the image size and so on. You can add titles and everything, right? So this is visualization, very basic visualization. Now, I want to before we close, I want to talk of visualization of two variables at a time. And what is bivariate? How does one variable change with the other? Okay. Does anyone know what kind of plot we make for this? No, not a subplot. What kind of plot? To make a relationship between two variables. How do I see that? Can you say a purpose for which one to use rep? Uh, I'm not sure I understand what rep is, but can you just repeat, just elaborate on the question? What does rep mean? Which one to use to represent? I think that's what you meant, right? Rep. Okay, I'm not sure what it means, but uh, individual variables when you're looking at univariate analysis, box plots, histograms, something called density plot. These are useful ones. Actually, and for categorical bar plots and all is what you typically use. Okay. What else? Okay, I think this is fine. But yeah, so between two variables, how do you draw? Have you guys? Do you guys know what a scatter plot is? This is what a scatter plot is. There is x, there is a x-axis, there is a y-axis, and there, how the values are on the x and y. Okay, this is a very very useful, very helpful tool for identifying relationship between two variables. Okay, two again. So I'll two numeric variables. Okay, scatter plot is used for two numeric variables. For two categorical variables, you'll have a different plot. I'll talk of that. And for one categorical, one numerical, again, you'll have a different kind of a plot. Okay, I'll talk of those. But for now, first one, scatter plot. Okay. And I can just say IMG SRC. Because don't worry about how I'm doing these things for now. And let me see, 300. Oh no, I need to increase the width. Okay, this is how a scatter plot will look. So this is what scatter plot. It in one view gives us a relationship between the two features, ideally both numerical. No one is stopping you to use it for categorical, but it just won't make sense. And this will give you a lot of idea about what the variable association is. So for example, in this case, in one look, you can tell that, process input, right? As it increases, the quality characteristic decreases. There is a downward trend, right? You see that, right? There's a downward trend. It's a very, very useful thing to see. Okay. So in our and there's in our data we have some numerical columns, right? So say in our data inp1 dot columns, sorry sales one dot columns. So we have we have discount, we have profit, we have unit price, shipping cost. All of these are product based margin. All of these are numerical. So we can explore quantitative, or we can explore this relationship between two. Let's take any two. Okay, let's take product base margin versus what unit price. Okay, to see if higher priced items, right, you would expect, right, higher price items may have a higher margin also, right? That's what you typically expect. Let's do that. Let's see if it is possible. So I can use plt dot scatter. Okay, so what does it need? It needs the x, it needs the y. You can do a lot of other changes also. See, maybe it's better you guys explore it later yourself. But there's a lot of stuff you can do here. Okay, x, y, this and so on. Let me do this. Let me take this plt dot scatter sales one, and from that I want, what do I want on the x-axis? X-axis, let me get the unit price. Okay, and what I want to see with unit price, does the base margin also increase? Okay, product base margin. Okay, this is the basic stuff. No other arguments provided. What is happening? What kind of relationship do you see over here? Is there anything at all? Yeah, okay, so that doesn't look like there's much. But remember, again, okay, remember that 1,000 is actually, when you saw it, was a very high value in your data. You probably don't want to do this. You don't want to look at, when you're doing this kind of an analysis, right? Probably want to ignore the records where the values are much higher. Okay, so what I can do is this. I can use, in fact, there's one more way to do this actually. I can say y equals this product base margin. I can say, in fact, there's another way, just wait, syntax to do this. X equals unit price. I say data equals to sales one. This is equivalent, by the way, okay? And here, instead of taking everything in sales one, I can say take only where unit price is less than 1,000. Okay? See what's happening, right? X is unit price, Y is product based margin, data is sales, but I've limited to records where unit price is less than 1,000. So that this extra part just goes away. It's not helping me. Then I can see what is really happening. All right. Okay. So there's still nothing. That's a different thing, but it's like it's much more clear now, right? And let me see what was the quantiles or whatever we got, right, for unit price. What was the median 75th percentile or whatever? Sales one. Oh, unit. 70% was 85. Oh, so I need to limit to like less than 100, not 1,000. Yeah, so even there's not much actually. Still all, very similar kind of a thing. So from this, I do not see that higher selling items have higher margin. Yes, guys, do you agree with me? Okay, let's look at something else. Okay, um, let's look at profit and the unit price, right? I think you pretty much know this, but yeah, X is unit, so X is unit price, Y is profit, and unit price less than 100. This time let it be 1,000. Okay. Yeah, now there is something a little better. Let me, okay, let me do 100 was the better one. Now here, do you see something? What do you? Okay, so one way to look at this, see, in general, it looks like, see that this is goes up, okay? It looks like as your price increases, the profit is increasing, but there are cases where the profit is negative. And the thing is, we don't know what's wrong with this. Okay, these orders could be just return orders or whatever. Okay, so this is one thing. Let me also draw PLT dot H horizontal lines y equals to 0. Oops, y equals 0, x min 0, x max equals 100. I drew a horizontal line, right? Uh, Shit, I forgot what to. Forget it then. Style or whatever. Yeah, is it okay? X min. So I drew a horizontal line. You see that now. There are more things above than below, and also you see this part, things are going up. All right, and in fact, if I just make the same image again, see, because it could be that the lower, that it could be that those cases are the cases where there are some returns or whatever happening. Okay, and let me make this again, and let's say profit is, let's say, greater than 0. Okay, for only profit cases, let me see what kind of curve this happens, right? I'm just removing the part below this, and I don't need this horizontal line now. Okay, in this case it does seem like, okay, line equals to, okay, line equals to dashed. Okay, no, yeah, it doesn't work. But no, there was something else which I just forgot. Period line. But anyway, you got the idea, right? It's about what the final message is. It's not about the exact syntax and all. I don't care about actually. Line style equals to solid. Line style is equal to dash. Yeah, yeah. It wasn't just lines. Right, so dash line. So yeah, but now if I let's say I, those were like return orders, but if I see the non-return orders, I do see that, yes, I mean, while there's a lot of noise or variation, I do see that in general that as the price increases, the profit also increases. Yes, you guys agree? Okay, cool. So now essentially we are looking at bivariate. So one last, actually, I share this notebook with you. I think we're out of time also. I think we just reached the bivariate analysis part and so on. Just one last thing I want to just show. I don't need to explain it so much. Um, so let's say, how does the, let's say, discount vary for each category, something of that sort. Or maybe, okay, so remember earlier we had these categorical values, right? Ship mode, different ship modes I had, and for different ship modes, delivery, truck, express, and regular air, right? uh, if I want to see, if I want to understand, right, what the order values for them are, remember? Um, so for each ship mode, what the average order values are like, and I want to plot them on a bar. Okay, average order values for different ship modes. Plot them on a bar or on a chart, right? Bar chart. This is your bivariate analysis because you're taking ship modes, which is one, average order value, which is a separate one. Okay, so, and not average order value, I think it should be sales, average sales. Okay, so what I'll do is, remember how to do this? You have to do a group by. Okay, group by. Sorry, not just like this. Sales one dot group by. What will you group by? Ship mode. Let me just make sure I get this right. Yeah, ship M capital. Good thing I checked. Ship mode. What do you want to group? Sales. Yeah. And then I will do what? Mean. And I get this. And the last thing I can do is plot. And if I do a plot, by default it gives me a line. I don't want that. Dot bar. Yeah. And just to make sure color equals to, I don't know, whatever, dark. Okay. Or let me make it bar h. So now I know that delivery truck, this is one of the things you're discussing here. Delivery truck, the order values or the sales for them are the highest. And the reason could be again that the more heavier machines are what we are selling or we are sending by delivery trucks. Okay. This is, and between regular and express air, even though earlier also there wasn't much of a difference in the split, here also there's much of a difference in the order values. Okay. So that's one way to analyze two categories. Let's say a category and a numerical feature. Aggregate by the categorical variable, do aggregation on the numerical variable, whatever it is, and then do a plot. You don't have to have a mean, you can have a median also, by the way. So see, much big difference now. Again, so on. So it's up to you how you do this. But yes, the median is a better one in many cases. We know there's extreme values, right, in sales. So median is a better one. Okay. This is how you start to analyze multiple variables at a time. Okay. So guys, that's 1 second. Share this file. Okay. So how many of you could code also? Okay, good for you. I won't share the file. No, I will share the files. Okay, and I think Board Infinity will take their own time in between, so I can't share directly with you. But yeah, probably have to just, I'll share with them. They will just share it with you. Okay. All right. So the last one, I think we moved faster. It's these syntaxes are larger, but I am assuming the things before you guys were able to plot all of this, okay, without any issues. Now we're getting into serious plotting and serious analysis now, guys. Okay, we're already like scatter plots and everything. You're doing bar charts by something and so on. And I think this is the introductory part of data analysis. This is sufficient. When we continue, what I want to do is answer more complex questions. Okay. So next session, whenever we have what we'll do, I'll talk of that first. Next session, whenever we have, we will do more of this analysis on the same data set. And then I will explain to you what you have to do in your assignment. All right. So that's both. Okay. I'll define the data set in the assignment and what kind of analysis you want to do on the data set. All right. So yeah. So next, but please be sure to practice these things before we come to the next session. I don't want to spend time again on this thing. And I'll also, by the way, work with Board Infinity guys to figure out if you can have some sort of an assessment in the beginning of session so that we go ahead with the students who are serious. I'm okay teaching only 5, if that is what it means. Okay. So yes, be prepared. We may have some sort of a test also. Okay. So you go through these and be prepared. Okay. In case you want to attend the next session, I strongly suggest that you go through these. Okay. Cool. All right, guys. That's all from my side. Have a good day, a remainder, and we'll meet again somewhere in the middle of the week, I think. So yeah, just make sure you have covered decent material so far. Just make sure you go through these. Okay. All right then. Goodbye from my side.